channel. Today we shall be looking at the model development steps in machine learning or deep learning or whatever AI research project that we have. And I love the way they put it in this book. I highly recommend the book, Machine Learning and Data Science Blueprint for Finance. You may want to get that. Now here they listed the 7 steps that are part of model development stages. The first is the problem definition, and that's very critical. That's very important. You need to first identify what are the goals of the system you want to develop. Without having a goal, it's like shooting in the dark. You really don't know where you're going. So you need to have a goal, a definite goal. Now, I will adjust this by saying that as part of the problem definition should also be the metric definition. You should define the metrics, the performance metrics. How do you know when you have reached the goal? It's just like taking up on a journey. Yeah, you know that I'm going from A to B, so that's the goal. To go from A to B. But also, you need to know the metric of when you have actually arrived at the location B. You need to know upfront whether you want to arrive at that location, if it is okay by you to arrive within a day, or within an hour, or within 2 weeks. So that's also that should be part of the problem definition. So you're looking for a particular value. So you need to have quantitative metrics and qualitative metrics, as the case may be in some situation. So quantitative has to do with a particular number, a particular value that you feel you cannot do without. Anything below that is not acceptable for you in terms of accuracy, or in terms of a loss function. Anything above that is not acceptable. So problem definition is very critical in the life cycle, in the model development steps. The second one is loading the data and packages. I will refine this by saying identifying the data, because sometimes you might not even have the data within your reach, but driven by the problem that you have defined, you begin to sort for the data, begin to look for the data, whether it exists or it does not exist. If it does not exist, you begin to look for ways to be able to create or synthesize the data, or to merge different kind of data to get what you need. So you need to look for the data, appropriate data that will answer, that will be a signal to the solution to the problem that we have already defined, or at the same time that will give us the kind of acceptable metrics that we perceive will give us the kind of acceptable metrics. So once you get the data, then the next is you want to look at how to load the data and the kind of packages you need. So when we have the data could be structured data, that is a tabular data, or it could be unstructured data, maybe in kind of images or videos, or it could be time series data, or it could be geographical data. Different kind of data, it could come in different format. All right, so depending on the data format, the structure of the data will also affect the way we load the data. And sometimes the data could be multi-modality, so it could be both structured and unstructured at the same time. So these will inform the kind of tools that you need to be able to merge these two different data sets together into one. Of course, the next thing is to do the exploratory data analysis. Here you try to do some data visualizations. You want to check the statistics of the data. You want to look at the maximum, the minimum, the average, the percentile. You want to look at whether there are imbalances in the data. You want to check whether there are not a value or non-value in missing values in your data set. You want to look at whether your data is in itself has some inherent biasness. Then you look at the features in the data, which you also call the attribute. You want to be sure that okay, the attribute and the features, they have consistency in their data type. For instance, you want to be sure that okay, all the age columns actually carries a number. You want to be sure that all the gender column actually carry just male and female. So that's a part of the exploratory data analysis based on previous studies understanding of what such kind of attribute should contain. The next is, according to them here, is data preparation. But I'm going to redefine this as not just data preparation. Here you also be simultaneously thinking about the model. Because if you're just preparing a data and you don't know the model, your preparation might go wrong. So at the same time, you have to do your data preparation and model selection at the same time here, so that your data preparation could be suitable for the kind of model that you want to feed it into. So to prepare the data, for instance, if you want to use it for, if you're using it for traditional machine learning, like random forest, like gradient boost, like support vector machine, you want to do some feature selection. You want to do some feature engineering to be able to select the most appropriate data that will probably give you the result you are looking for. You want to transform the data, trying to normalize the data. You want to bring some data into categorical format. For instance, if you have a column or attribute that has the gender, so it could only be male or female. So you want to transform that from a string into an integer of just two values, 0 and 1, and you want to make it categorical for efficient storage of the data on your disk space. All right, so you think about all that here in this stage. At the same time, you think about the model you want to use. For instance, if you're going to use a neural network, then you may want to do less of feature engineering there, because you know that your neural network is going to take care of that for you. So that's why I said concurrently you might look at the data and the model, the choices of model. At least you can just look at what are the top 2 or 3 models that you feel will be suitable for the work. Then you prepare your data in that like manner. Then if the data set is multimodal, let's say you're having a combination of tabular data and at the same time you're having some images or you're having some videos, then you want to see how you can pre-process those multimode data and do some, maybe to match them or do some feature extractions and to be able to feed them into the model. Now this is where I disagree a little bit. From data preparation should be training of data. That is missing here. So from data preparation you should have training and evaluation of models. Maybe you could match it that. So not just to evaluate model, you need to train the model. You need to train the model. Here you have to decide how you want to train the model, whether you're going to train the model on premise or in the cloud or hybrid, depending on the sensitivity of your data, whether it's going to be a federated kind of learning because you don't want to expose your data to the cloud. So that has to be done here. Then you need to make a decision of how to split your data, so that you split into training, validation, and test. What percentage should go into each of those? And you want to be sure that your data set takes care of data distribution shift, and you want to be sure that when you have a time series data, you don't shuffle your data, because that is going to inherently cause some leakages. So there's a lot to do here in the training of your data. Then there are a lot of hyperparameters you need to define how long you want to train your models in terms of the number of epochs. Then you also want to know whether you should babysit your model, at least you try some subset of the data set and see that your model is able to overfit the data. That means your model is complex enough to be able to learn the patterns in your data set. So then you evaluate your model based on the validation set. You keep the test set away. You evaluate your models. Once you evaluate your model, this will be an iterative process. After evaluating your model, you might decide that, oh, I need to tweak again the model hyperparameters, maybe the number of layers if it's a neural network, maybe the number of uh, trees if it's a decision trees. So you you do that all here. Then identify the evaluation metrics. Of course, all along here you carry on this problem definition, the problem you are defining, and the metric. You carry them all at the back of your mind all along the stages here, because at any point in time, if anything violates your problem definition and your metric that you have defined, then you may have to backtrack. You may have to do some iteration here to be sure that you're keeping in mind those goals are not shifted away. And you train multiple models and do some comparison if you have ensemble models. Then here, then you tune your model and enhancement. I've kind of touched on this in this place. As I said, this place should actually be train the model. Maybe this should not be evaluate and tuning. So I will readjust this as such. So you tune the model, the hyperparameters, you look at different learning rate, and you kind of look at the different kind of tunable parameters, number of epochs, number of layers in your model architectures, and all of that. Then once you're done, is once you are sure you're good, and at this stage, your final model that you have chosen, you selected, has actually met one, your problem definition, two, your evaluation metrics. Then you can now go and finalize your model. That is, you actually run that model on the test data to give you an idea of how your model is going to perform in the wide world where you are not able to control it. Then you save and deploy the model. Maybe it's going to be on the web or in the on mobiles or embedded device, as the case may be. I'll also make another adjustment to this, that this should be an iterative process here. After you have finalized the model here, there should be a place whereby you this should go back to this place, because it's an iterative process. You cannot just develop, for instance, a fraud detection system 5 years ago and just leave it like that running. There might be new emerging threat that your existing model may not be able to take care of. So this should cycle back to this place, I guess, as long as your problem definition and your metrics does not change. But if it does change, then it has to cycle back to this evaluation metrics. Maybe before you are okay with just 20% loss, but now you're not okay with 20% loss again, so that you have to refine your problem definition. Maybe now you are comfortable with just 5% loss, so you have to go back here and go back through the iterative process to retrain your model and make sure it actually meets your new defined criteria. All right, thank you very much, and thanks for listening, and see you in the next one.